Hi students, today we are going to discuss the basic operations on sets. Children, we all know that arithmetics has some basic operations like addition, subtraction, multiplication and division on numbers. These things we know. Similarly, on sets, we define some operations like union, intersection and difference of sets. So, among these operations, today let us discuss union of sets, right? So, what is union of sets? Suppose there are two sets like set A and B with some elements in each of them. Then the union of A and B is defined as the set of all the elements of A and B. Means, suppose there is an element X belongs to A and there is an element Y belongs to B. Then union of A union B is nothing but set of X and Y, both. Okay? Now let's see, the definition of union of sets is like this. The union of A and B is the set which consists of all the elements of A and B. Okay? And the symbol that we use to define or to denote union of sets will be like this, right? So this is read as union, A union B. So how it is defined? See here, set of X such that X belongs to A or X belongs to B. So X can be an element of A or it can be an element of B. So all the elements consisting from A and B put together forms A union B. Now how do we define or illustrate the union of sets in Venn diagrams? Let's see now. Venn diagram. Okay, now let us consider one universal set mu. Children, we know that mu denotes the universal set. Okay, in this there are two sets like set A and set B. Now the union of A and B will be like this. So total shaded region is the A union B. So A union B will be the region which has the shading. Okay. Now this is the way of representing A union B in Venn diagrams. Now let us see some problems on this operation, union of sets. The first one is like this. A is equal to set of 2, 5, 6 and 8 and B is equal to set of 5, 7, 9 and 1. He's asking us to find A union B. Now let us find A union B. Okay? See here. A union B is equal to, first let me take the set A. Set of, what is A? 2, 5, 6 and 8 union, take set B, set of 5, 7, 9 and 1. That is equal to, children, we have seen the definition of union of sets. What is union of sets? Union of A and B is nothing but the set of all the elements of A and B. So we have to write all the elements of A and B. What elements are present in A? Let me write first. 2, 5, 6, 8 and then see B. Those elements also will be there in A union B. 5 is already there, we have written. We know that the elements must be distinct, means we should not repeat the elements. So we have written already 5. Okay, we need not to write it again. 7, 9, 1. So therefore A union B is equal to set of, let me write in order, 1, 2, 5, 6, 7, 8 and 9. So these are the elements present in A union B. Now let me represent same thing in Venn diagrams. So let's see here, Venn diagram. So first let us consider the universal set mu, and in that there are two sets A and B. Now see here children, in set A and set B there is an element common, 5. That means both the sets have one element in common, that means they are joint. So let me write like this, set A, set B, and this part or this portion is the intersection of both the sets, right? Now, or the common area. In that common area, what elements are in common? Let us check. 5 is the only element in common. Now, in set A, what elements are present? 2, 5 is there in the common area, 6 and 8. Now, in set B, what elements are there? 5 is there in common area of A and B, 7, 9 and 1. Okay, let me write here, A union B is equal to set of 1, 2, 5, 6, 7, 8 and 9. So this is the way of representing A union B in Venn diagram. Here is one more question. Let's see that one. A is equal to set of A, E, I, O and U. Children, we know that they are all the vowels of English alphabet. Then B is equal to set of A, I and U. Show that A union B is equal to A. This we need to show. But before doing that one, let's see here what elements are present in set B. Let us see A, I and U. And see here, A is present in A, I is also present in the set A, U is also present in set A. That means all the elements of B are also the elements of A. Then B must be a subset to set A. So B is a subset to A. Then he is asking us to show that A union B is again A itself. Let's do now. A union B set of. Let me take set A first. What is A? A, E, I, O and U union B. What is set B? Set of A, I and U. Now let me write. So what is A union B? We already know that A union B is nothing but the set of all the elements of A and B. Now let me write all the elements of A and B. A, E, I, O, U, and then again see here A already written. So A already came, I is also there, U is also there already. Then this is the union of A and B. Children, we know that the elements in a set must not be repeated as they are distinct elements. Okay. Now this set of A, E, I, O, U is nothing but set A. So we got A union B is equal to A. That means if B is subset of A, B is a subset to set A, then A union B is nothing but A only. This is what we understood from this problem. So when B is a subset to A and A union B is again A. Let me represent same thing through Venn diagram illustration. See here. Generally, we represent the universal set using a rectangle, and that is denoted by the letter mu. And now A is a bigger set, B is a smaller set in A, means all the elements of B are there in A. That means B is a subset to A. B is a subset to A. Like this we represent. So B is inside A, as every element of B is an element of A. Now what elements are there in B? Let me write first. A, I and U. And in A, other than A, I, U, what elements are present? Let's see here. A, I, U. Then remaining elements are E and O. So A union B is nothing but set of A, E, I, O and U. Now this is the representation of A union B through the illustration of Venn diagram. Let us see one more question to understand the concept of union of sets. Here is the question. A is equal to set of 1, 2, 3, 4 and B is equal to set of 2, 4, 6, 8. And then we need to find A union B and B union A. Then he is asking us that what do you observe? First, let me find what is A union B and what is B union A, and then we will see what we observe. Now let's see here. A union B, we need to find. A, initially we have to write set A. Set A consisting of 1, 2, 3 and 4 union set B. And B set consists 2, 4, 6, 8. Now let us write the union of A and B. Now union of sets is nothing but the set consists of all the elements of A and B. Now let me write all the elements of A and B. 1, 2, 3, 4. 2 is already present. 4 is already present. Then what elements are left? 6, 8. So 1, 2, 3. Set of 1, 2, 3, 4, 6, 8 is A union B. Now let me find B union A. Here the order is changed. First we need to write set B. What is set B? See here. Set B is nothing but set of 2, 4, 6, 8 union and then A. A is set of 1, 2, 3, 4. Now let me write the union of B and A, means all the elements of set B and set A. The elements are like this: 2, 4, 6, 8, and then from here 1, 2 is written already, 3, 4 is already written. So that's it. Now let me write the elements in order: 1, 2, 3, 4, 6 and 8. Now we got B union A. Let me check what elements are present in A union B. 1, 2, 3, 4, 6, 8. And in B union A, 1, 2, 3, 4, 6, 8. Here, same elements which are there in A union B are there in B union A. That means A union B and B union A are the same sets. Therefore, what do you observe? Here, we are writing what we observed. Therefore, A union B is equal to B union A. This is what we observed from this solution. Here is a question. If A is equal to set of 6, 9, 11 and B is equal to empty set. See here, B is an empty set or a null set, means there are no elements present in set B. Such sets are called empty sets or null sets. Now we have to find A union 5 or A union null set. Now let's find here. A union 5 is equal to, first let me write the set A, 6, 9, 11 union 5, which is a null set or empty set. Now let me write the union of these two sets. Union is nothing but all the sets, elements present in both the sets. So let me write all the elements present in both 6, 9, 11. There are no elements, so we are not writing anything like this. So now, after the union, again we got 6, 9, 11, nothing but set A. So we can conclude that A union 5 is nothing but A only. Similarly, we can say that A union 5 is equal to 5 union A is equal to A again. Students, we have seen A union B. Now, let us see the second operation on sets, that is intersection of sets. So, what is intersection of sets? Suppose there are two sets, namely A and B. There are some elements in A and there are some elements in B. Now, the intersection of A and B is the set of elements which are common in both A and B. Means the element must belong to A and must be belongs to B also. So such common elements set is called intersection of the sets. So the definition will be like this. The intersection of sets A and B is the set of all elements which are common in both A and B. So the common elements are taken in intersection. Now we generally represent the intersection of A and B like this, and we read it as A intersection B. The inverted union symbol is taken as intersection. Okay. Now A intersection B is the set of element X such that X belongs to A and X belongs to B. That means X is a common element of A and B. So children, we will see the intersection of sets in Venn diagrams. Let us illustrate intersection in Venn diagrams like this. Generally, a rectangle is taken as the universal set mu, and there is a set A and set B. Now, the intersection is this area where the common elements are present. So, A intersection B is the area of shaded region. Okay, like this we represent A intersection B in Venn diagrams. Let us see a question on intersection of sets. Here is the question. Find A intersection B when A is equal to set of 5, 6, 7 and 8 and B is equal to set of 7, 8, 9 and 10. So there are two sets A and B. We need to find A intersection B. Let us find now. A intersection B. So let me write the set A in the beginning. So which contains 5, 6, 7, 8 intersection of set B. What elements are there in B? 7, 8, 9 and 10. Now set A intersection of set B. We already discussed the definition of intersection of sets, and that is the set of common elements in both A and B. Now let me find the set of common elements in both A and B. So which elements are common in both the sets? Children, let us check here. 5 is not, 6 is not. Now see here, 7 is the common element and 8 is the common element. So now this 7 and 8 are the common elements. So let me write that 7 and 8. Now this is A intersection B, set of 7 and 8, the set of common elements. Let us represent the A intersection B in Venn diagrams. Now this is the universal set mu. In that, two sets are there, set A and set B. And set A consists of 5, 6, 7 and 8 are the common elements. This portion is the common area for A and B, and the set B contains 7, 8, 9, 10. Now A intersection B is equal to, now this is the area where seven, 8. So this is the intersection area. 7 and 8 is the set of A intersection B. Now here is the question. Set A is set of 1, 2, 3 and B is set of 3, 4, 5. There are two sets given, A and B, and he is asking us to illustrate A intersection B in Venn diagram. So let us do the illustration. Generally, a rectangle is taken to represent the universal set mu, set of A. Sets are taken the curved shapes, generally the circles or ovals. B, now set A, set B. Now there is a common area. This is the intersection area. And what element is common in both set A and B? Let us see. 1, 2, 3, 3, 4, 5. Now I can find 3 is the only element in common. So let me write that in the common area. Other than 3, what elements are present in A? 1 and 2. Other than 3, what elements are present in B? 4 and 5. Now 3 is the common element. Now this is the common area. A intersection B is equal to set of 3. Here is one more question. Now set A is equal to set of 1, 2, 3 and B is equal to set of 2, 3. Then find A intersection B. Okay, let me find A intersection B. A intersection B is equal to set of A is 1, 2, 3 intersection B. B is set of 2 and 3. Now let's see here, the set B contains the elements 2 and 3 which are already there in A. Means every element of set B is an element of set A. That means B is a subset to A. B is a subset to A. Now how the intersection will be? Let's see here. Obviously the common elements are 2 and 3. Now set of 2, 3 is A intersection B, which is actually set B. Means A intersection B is B only. Then what we can find from this, what we can observe from this, let us see here. Here the set B is a subset to A and A intersection B is B. We can write like this: if B is subset to A, then A intersection B is nothing but B only. Here is the question. A is equal to set of 1, 2, 3 and B is equal to an empty set. So here B is the empty set or a null set, which is also called as a void set. Now we need to find A intersection 5. Let me find here. A intersection 5. A is set of 1, 2, 3 intersection 5 is nothing but an empty set. There are no elements present in the set. Now, what is intersection of sets? We already know intersection of sets is nothing but the set of the elements in common for both the sets. So, which element is common in both sets? Is 1 common? 2 or 3 common? No. So, we can clearly find that there is no element in common. That means there are no elements. So we have to write an empty set as the result. Therefore, we can write A intersection 5 is nothing but 5 again. So what we observed here, A intersection phi is equal to phi intersection A is equal to null set again. Now let us consider two sets. Set A contains the elements 1, 3, 5, 7, the odd numbers below 9, and set B contains 2, 4, 6, 8, even numbers below 9. Now let us observe both the sets A and B. Is there any element common? 1, 3, 5, 7, 2, 4, 6, 8. So it is clearly we can say that there is no element in common for both the sets. So there is no element in common. Then let us represent these sets in a Venn diagram. Mu is the universal set. Now set A contains 1, 3, 5, 7, and set B contains 2, 4, 6, 8. See here, it is clearly we can see that there is no element in common. And these two sets, when there is no common element present, are called disjoint sets. So we call such type of sets as disjoint sets. So what are disjoint sets? Let us see once again. If there are no common elements in sets A and B, then such sets are known as disjoint sets. So since there is no intersection part, A intersection B will be null set. A intersection B is equal to 5 is a null set. So A, B are disjoint sets. Now let us see the third operation, the basic operation on sets, that is difference of sets. Now let's see here the difference of sets, how it is defined. Suppose there are two sets, set A and set B. There are some elements in A and there are some elements in B. There could be some elements which are common in both A and B. Now the difference A minus B is the set of elements which are present in A which belongs to A but not B. Such set is called A minus B, and it is defined like this. The difference set of A and B is the set of elements which belongs to A but not belong to B. It should be there in A but not there in B. Then it is called A minus B, and we write like this: A minus B is equal to set of the element X such that X belongs to A and X does not belong to B. Now let me define or illustrate A minus B using the Venn diagram. Here it is the set universal set mu, and here is the set A, set B. Now A minus B, from A subtract B or remove B. So we should not enter into B, the common area. So only purely A area. This area is the A minus B area. A minus B is the shaded region. Now, to understand the difference of sets, let us do an example. And here it is. Let A is equal to set of 1, 2, 3, 4, 5 and B is equal to set of 4, 5, 6 and 7. We need to find A minus B and B minus A. So in the beginning, let us find A minus B. A minus B is like this. Initially we have to write set A. Set A contains 1, 2, 3, 4 and 5 minus B. set B contains 4, 5, 6 and 7. Now what we need to write? We need to write the elements which are present only in A but not in B. So there could be some elements in common that we have to omit. What elements are there? See here, 1, 2, 3, 4 is the common element. Let me cancel that, and 5 is also there. Yes. Now A minus B means the elements present only in A. What are they? 1, 2, 3. Children, you need to be a little careful. We have to omit all the elements of B where even the elements which are in common. Okay. Now set of 1, 2, 3 is A minus B. Let me represent this one in Venn diagram quickly. This is the universal set mu, set A, set B, and now this part is the A minus B area. Now what are there? 4 and 5 are common, and 1, 2, 3 are there in this area, and other than 4, 5, 6, 7 are there in B. Now A minus B is nothing but set of 1, 2 and 3. Now this is the Venn diagram. Let me find B minus A. So we have to write set B in the beginning. Set B 4, 5, 6 and 7 minus A is set of 1, 2, 3, 4, 5. Now 4 is the common element, 5 is also the common element, that's it. Now what elements are left in the first set? They are the answer, set of 6 and 7. Okay. So now let us represent same thing in Venn diagrams. Mu is the universal set and B is one set and set A. And now B minus A is the area where only elements of B are present. Means this one, the shaded area. Okay. Now, what elements are present? Let's see here. In B, 4 and 5 are common elements. Other than 4, 5, 6 and 7 are present here. And in here, in this area, 1, 2, 3. Right. Now, B minus A is nothing but set of 6, 7. Here we got set of A minus B is 1, 2, 3. And B minus A is set of 6, 7. Children, are they equal? No, they are not equal. So what we observe from this? Therefore, A minus B is generally not equal to B minus A. This is what we find. We have discussed the basic operations on sets, that is union of sets, intersection of sets and difference of sets. And we have even solved few problems based on these operations. And now here are few questions, and that is for you. Try to solve them.